Hey, good day to you all. I was asked by one of my subscribers if I could make a video on the artillery fire correction. Uh, well, artillery fire correction, or forward observation, or observation, or whatever you want to call it, it's an art of its own. So it is another profession. Uh, I'm trying to explain the basics here, or some basic method that you can use for your everyday armor playing if you want to play around with this topic. Well, in order to do that, what I did, I installed M252. This is the um, vanilla Ace M252, because the point here is not to find your azimuth or elevation. You are just using the artillery scanner, and that way we save a lot of hassle, and we can focus on the fire correction itself. What we need also target. I just designated some target here, whatever. So a couple of BM21s standing over that, and we have our mortar here. And what you need is obviously distance, elevation, and whatnot. It is the range table to find out your solution. Well, let's do it. With this video, I also wanted to show you the plotting board, the ACE inbuilt plotting board, which is a pretty funny thing, and it is very easy to use and somewhat fun to mess around with. The plotting board is a very useful tool for a lot of things. The resilience of things, you can plot any solution, whatever you want. The simplest what you can do with it is obviously to measure distances and azimuth. So you see, I'm trying to get the azimuth to my target. Here I put the center of the plotting board to my target, and I'm trying to find the azimuth. This is a no-news scale, and you see I'm reading the red one, and this is the middle one, is your main marker. And if you are making a reading clockwise, you use this part of the scale. If you are making a reading counterclockwise, you use this part of the you see, it is the 51, 50, 58, 58, 1, 58, 2, 3, 4, 5, 6, 7. So it's 58, 7. Let's just put it down. So the azimuth to our target is 58, 1, 2, 3, 4, 5, 6, 7. 58, 7. Let's find the small digits. You see, whatever red line aligns with the black one, it is this one, I guess, which is 1, 2, 3, 4, 5, 6. So the last digit is 6. 58, 7, 6 mils. That is my azimuth to this target, and the distance is pretty easy to find. The distance is pretty easy to find. You just need to align. And you see, every well, between these thin lines, the distance is 50 meters. So you see, it's 2000, 2050, 2100. So the distance to my target is 2100 meters. That's it. What you need to find, I'm doing here some hasty solution, because I don't want to calculate that much. So you see, the distance is 2100 meters. Charge 2 will not get there. Charge 3 gets there. 2100 meters. So my base elevation will be corresponding to 2100 meters, 1124 mils. 1124 mils. Okay, let's not calculate with the elevation difference because the purpose here is to learn about artillery fire correction. So two things you need to know to correct your artillery fire. Well, first, just for make things easier, let me just connect with the line. the mortar and target. Seems I'm a little bit sick here. And in that way we can it's going to be a somewhat easier to fix things. So what you need to know, well, there is, to correct artillery fire you need some form of observation. Nowadays it is pretty much done with drones, but in a good old time it was just eyeballing your target from an elevated point or whatever, and you relayed back the information where the impact was relayed in reference to your target. Well, there are trillions of methods to do that, but the Soviet method is using the cardinal directions. So if let's say here is my target and I have an impact like whatever here. See, I have an impact. This is my impact point. So I will relay back the information that the impact point was what? It's 50 meters, it's 100 meters to the north. 100 to the north. And to get to my impact point, I need to move west. And it's 50, 100, 125 meters. 125 to west. And what the artillery people do is they just plot it out. You see, they also plot it out the impact point using the cardinal directions. And what they do is they have their plotter. They will just have their plotter. They plot out the impact point. And what they need to do is they will rotate the plotter the way that it will be aligned with your direction of fire. You see? What's the point of that? Because it will show you from your perspective, from your line of fire, the impact point, the corrections you need to note using your cardinal direction. That means your range and your azimuth. You see? This is how you change your range. In that way you move on the whatever from your reference direction. This is the horizontal vertical direction, and this is the horizontal direction, but this is the cardinal direction, vertical and horizontal. But you need to turn it to your way, because you can only change your elevation and your azimuth. But how much you need to change your elevation and azimuth, you need to calculate a little bit. You see, from my perspective, I need, for example, to aim shorter. How much shorter? Well, 50, 100, 150 meters shorter. So my shot is overshot by 150 meters. In order to correct for that, I need to know what 1 mil of elevation change, how much range change it will result in that particular distance. Well, in order to do that, all I need is my range table, and I see at 2,100 meters. I really need little calculation I need to make here, because at 2,100 meters the corresponding elevation to that is 1124 mils. But you see, the next distance, what my range table is calculated for, is 2,150 meters. 2,150 meters, and the corresponding elevation to that is 1107 mils. 1107 mils. You might pretty much now, well, guess what I'm doing here is, you see, 50 meter difference. I'm calculating how to explain it? Sure. Briefly, here you have 50 meter range difference, and you have what? How much? 17 mils, I guess. Let me calculate it. 1124 minus 1107. That gives me 17 mils. So 17 mils of elevation difference gives me 50 meters range difference. How do I calculate that 1 mil of elevation difference? How much range difference will result in? Well, it's simple. I just divide 50 by 17. You see, that is 2.9 meters, 2.94 meters. So at that given range, 1 mil of elevation difference will result in 2.94 meters of range difference. You see, so in my particular theoretical case, I need to aim 150 meters shorter, closer to myself. So what I do is I need to aim 150 meters closer. I divide it by 2.94. It gives me that I need to change my elevation 51 meters. But which way? Since I am shooting here mortars and they are high angle, to shorten my range with mortar I need to elevate it. So my elevation correction for that shot would be plus 51 mils. I just add 51 mils to my whatever elevation I shot my first shot with, and I just add 51 mils and it should compensate for that difference. Here I have also another thing I need to correct for. It is my azimuth. You see, from my perspective, the impact point is 50 meters to the left, so I need to move my impact point 50 meters to the right. Well, it's also pretty much the same procedure. You need to use that 1 mil of azimuth change. How much will move the impact point left or right? Well, and here comes the beauty of the mil system. The mil system is pretty simple, because the milliradian basically means that at whatever radius you are, if you move your perspective 1 mil back and forth, on the circumference of the circle, it will result in the 1/1000th of the radius. So it sounds difficult, but it is easy, because if you are shooting to 2,100 meters, that means if you change 1 mil your perspective or whatever your azimuth, that at that distance it will result in 2.1 meters. 1/1000th of the radius is 2.1 meters. It will change left or right. So in my case, well, I need to change 50 meters. So let me put it down. So 1 mil of azimuth change at that distance will result in 2.1 meters of left or right. The impact point, it will move by 2.1 meters. I need to move 50 meters. What do I do? Well, I have 50 meters and divide it by 2.1, and I got that it is 23.8 mils. But which way? Since I want to move my impact point right, I need to add it to my actual azimuth. So my azimuth correction would be plus 23.8. that's round up to 24 mils. So that is how basically the correction is calculated and your plotter is used for artillery purposes. I hope you understood it, and if you have further questions about it, just let me know it. The ACE plotting board is pretty much an accurate representation of the actual US M whatever plotting board, which is a very, very handy tool. If you want to try to use it, it's a very good and very useful thing to plot anything, any distance or whatever. You can work without any map or whatsoever. So I hope you understand and you enjoyed it, and if you have any questions, please just post it under this video. Thank you so much and have a wonderful day.